This is Nicholas Regano, SE 456 Sprint 1, going over the manager class. On the right here, we can see the UML diagram. Pretty much matches the PDF exactly, but we can see that there's two pointers, active and reserve, and they both point to list base. So really all this section over on the right is, I guess, duplicated. One time for active, one time for reserve, separate lists. And we can walk through the find function over here real quick to show that off. So this stub was provided at the start, and we're looking for a node by name and returning a node. So first we go to our active list and we get the first node in there, but this is going to return as a node base. Um, since we want to look through at the name, we're going to need to cast it to a node, and this can live as a node. That's kind of what we'll need to do. So we'll initialize that as a node. We'll go through, and as long as it isn't null, we're going to perform a check and check the name of it. If the name matches, then we found our node and we can just return the node. Um, didn't say anything about removing it from the list, so I have kept it on the list here and we just return the node. I'm assuming this will be used if we want to get some value or query that node for some reason. If the name didn't match, then we're just gonna move on to the next node. And you see we casted this to a node type as well. That's because using pnext, that's, as we can see over here, it's in the slink abstract class, so um, it's going to return an slink, this pnode.pnext, and we'll need to cast that back to a node since that's what we're checking. If we get to the end and we don't find anything, we're just going to return a null. That's because the list was null. There's no nodes in it, so you can't really find something that doesn't exist. And just to prove it all works, we're going to run it. Nothing shows up here, obviously, so we're going to hit escape. And we see that we're passing 4 tests. And we have them all enabled. Thank you.